Yeah.
It says going live. It says live. Okay. Third time's a charm. Let's do it. Okay. All right. So here you go.
Doing it live, why don't you just record
What?
it? You say you have to do like extra videos, why don't you just record it while you're doing it and then put them up after class?
That's what I would have to do. Yeah. I wanted it to be ideally you could do it live if you wanted to be there live, but that might be.
Like if it doesn't work, you don't necessarily have to do like completely different videos.
Yeah, I might just do like have to just record them, but that's a good idea, right? Okay, so there you go. This is number one. right here. Boom. All right, racing it. Hopefully you guys figured out number two.
Working on it.
Number two.
Number two.
So. All right, so there's the function. Who can tell me one fact about this function? Anyone? X can't be 2. And then what does that create on the graph? A vertical asymptote. So just like the first example, this one also has a vertical asymptote. This asymptote's a little bit different though. It has different behavior than the first one we looked at.
Yes, it does.
Okay. So because of this square,
Oh, yeah.
you might call this an even asymptote as opposed to an odd asymptote. So, so what you should expect on this, and it's not too complicated to understand why this is the case. That this asymptote is going to have this type of behavior. It's either going to be this type or this type. It's not going to be this type. Because this square, what that does, imagine x was 2.1, right? The top's positive, and the bottom's guaranteed to be positive, right? As long as x is in 2. So if x is 2.1, you'd have positive over positive. Great. If x is 1.9, you still have positive over positive. So in both cases, you're positive. So you're both on either side of the asymptote. You catching this, Alyssa? You getting all this? Okay, so on both sides of the asymptote, it's going to be a positive y value. Okay. As opposed to our last one we went over, where it actually flips from positive to negative at the asymptote. So something worth knowing. All right, who can tell me something else about this graph? Anyone?
X-intercept of 1. No, sorry. X-intercept of 1, 0.
Very good. The x-intercept is 1, 0. How about, does anyone know the end behavior?
Approaches 0.
Jesse got it? Yep. It's approaching 0 on both sides. So how come it's approaching 0, Jesse? What's the reasoning there?
Because, well, when it gets really big, when x gets really big, it's really close to 0. The top over the bottom, right?
Correct, but
I mean, like the bottom gets really big, and the top is not as big because it's squared on the bottom, so that's getting really close to 0.
very good. So the bottom is, so if you look at the dominant terms, on the top, who's dominant? The x. On the bottom, who's dominant? If you expanded this, you'd have an x squared plus some blah, blah, blah. But you just look at the dominant terms, x over x squared, I mean, that's kind of equivalent to 1 over x, right?
Mm-hmm.
So the end behavior is going to be similar to 1 over x. So like she said, they both get big. The top and bottom are both getting large, but the bottom, because it's squared, is getting large faster. So we'd be approaching 0. So that means there's a horizontal asymptote of y equals 0. Okay?
Yeah.
Now, this one always, maybe not for you guys. What's the objection that you think people would make?
0. It's on the.
And what, you can't cross a horizontal asymptote? To which you reply,
Yes, you can.
Yeah, you can.
Wow.
Lamau. Yes, you totally can cross a horizontal asymptote. Nothing's stopping that. Y-intercept. We went over the answer earlier. You just plug in 0. So if you plug in 0, you get, when x is 0, you get negative 1 on top, positive 4 on bottom. So there you go. Here's the point 0, negative 1/4. So that's a nice little hint. Maybe you can see the shape kind of forming. Looks like that.
Boop-a-do.
Can you
Yeah.
cross a vertical asymptote? Not really. I mean, you can sort of artificially.
1.9 repeating.
I just mean you could technically you could have a function like, oh, it's 1 over x squared, and then just like add a point in there.
Oh, yeah.
And are you crossing it? But no, like on something like this, no, because you can't have a point on the asymptote because that x value is not allowed. So, okay, how about the right-hand side? This or
No.
this?
The top one. Ba-do-ba-do.
What we talked about earlier is another way you can reason that out is just literally pick any x value you want bigger than 2. 5, sure, 3, plug in 3. Positive over positive if you plug in 3. Plug in 5, positive over positive. You know the y values are positive if x is bigger than 2. So boom. All right, there you go. Beautiful. Look at that. Lovely graph. Looks great.
Yay.
If you graph it on Desmos, it might be a little different. Maybe this little Humpty Dumpty's lower or something. Who knows? But that's not what we're concerned with. We're concerned with things like domain, asymptotes. All right. Let us let's skip 3. Oh, you guys can just that's the one you do on your own. I want to do 4.
Oops.
All right, take a look at 4.
Oh, I keep writing things wrong.
Don't do that. That's
Lamau.
that's pro advice there. Taking the ACT,
Thanks.
don't get any questions wrong.
Thank you.
There you go. There you go. Yeah. So, okay, there's your function. Don't be afraid of the t. It's just, you can name, most of the time we name our function f of x, but you can name it g of x, h of x, t of x, q of x, whatever. You
Yeah.
could technically, I mean, yeah, as long as it's a capital X, yeah, capital X of little x. That'd be a little
That'd be
weird.
lame.
People might be like, why did you do that? Why not? Yeah, so there you go. Why? Why'd you do that? Why not? Why not do it? Okay, now looking at this, do you guys think you have an idea of like maybe what kind of end behavior this has?
Yeah.
Okay, very good.
Whee!
This guy.
Yay.
Look at the dominant terms. If that's unclear to you, look at the dominant term on top is x squared. Dominant term on bottom is x. That simplifies to x. So that's the kind of end behavior this function has. For large x values, it's going to behave like that. Okay. Luckily, this is the laptop this time, so that guy can beep. I don't care. I don't know what he's doing over there. That's fine. You know, Rafe, if I do just make just recordings, we'll have to get some software on there, but then I can put like Comic Sans, like things that like come on the screen and, you know, annoying noises, things like that.
That'd be like.
Yeah.
Just all over jokes.
Yeah, it's all the funniest things. Annoy the viewer. That's a principle of YouTube.
Only gonna be Griffin.
Yeah, it's just no, and make the videos as annoying as possible. Okay, so this guy, he has vertical asymptote, right? Of x equals -1, which goes hand in hand with the domain being all x values are fine except for negative. Those guys go hand in hand, right? Okay, what else? We got the end behavior. So the end behavior is as x goes to infinity, y goes to infinity. As x goes to -infinity, y goes to -infinity. Okay, why? Because that's the end behavior right there. It has y equals x type end behavior. Okay. Any x-intercepts that we care about?
Y, right? 1, 0. Wait, wait.
Yep, you got it. You're like, wait, what? How do you know that? You got to factor the top, right? Factor the top. That tells you the x-intercepts, right? 2 and 1. What would have happened, just throwing this out there, if this just happened to be an x plus 1 factor? That would create a hole.
Yeah.
I put all the hole questions separately so we can just kind of focus our attention on how those arise and whatnot on numbers like sort of 13 and 14. So none of these, unless I have a typo, none of these should have holes in them. But just something to keep in mind. So if you had the same factor on top and bottom, that would produce a hole. Anyway, so you have, here's your x equals, 2, 0 x-intercept, and then the negative 1, 0 x-intercept. I don't know why I put that dash there, that was silly. No need for that. Asymptote was at.
Wait a minute, yeah, I was
Don't
gonna
look,
say,
okay,
that's
still
not
look.
1-0.
Just testing you,
us.
just testing you.
Yeah,
That was all a test.
all I test.
Yep, just a test. Just
How
a
did I
test.
know that's what it was?
You're showing us what not.
Yeah, exactly.
Hey, what did that look like? I guess I found it.
Okay, so asymptote, negative 1. 1 and 2 are the x-intercepts. And then we know in the back of our mind, we're thinking of this sort of end behavior that's going to have to happen. And then what did I'm missing one other easy point to get on the curve. It's the y-intercept. So plug in 0. You get 0, 0, 2, 0, 1, 2 over 1 is 2. Yay. 0, 2. So now do you see it?
Yes. Does it like go under the Yes.
There's that end behavior. Over here, it has to follow this asymptote. It can't cross this axis either. So I know it can't do that. It's not the greatest drawing because I think, a more accurate drawing might look more like. That might be like way down here. I think if you Desmosed this, you'd see more like that. But we're not. As long as you get the end behavior and all that good stuff, you're fine. I think it would be fun to do 5 and 6 together because they're so interesting as a pair. They're interesting as a pair. Question?
How do you know that it comes from the top, like on the left side?
Here?
There, yeah.
How it comes from the top?
Yeah, like how do you know that there's no on both sides? That doesn't come from the bottom.
Okay, we should clarify that we're using the same language. Because I would say this is coming from the bottom.
Yeah.
Do you mean, are you asking how do we know it's not coming from the top?
Yeah.
Okay, so one way to figure that out is, there's a few ways. One is to say, that's a good question by the way, so thanks for asking that. But plug in any number less than -1. And let's see what happens. Let's name a number less than -1.
-3.
Sure. -3. Plug it in. You get negative, 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 which means your y value is negative. And if you think about it, any number you plug into this that's less than -1 will produce a negative y value. So that would ensure, for example, that all your points live below the x-axis. That's one way you could derive it down. Another way is we've already identified all the x-intercepts, and there's none over here. So we know that the curve can't possibly cross this line. And we also know that on the far left, it has to approach negative infinity. So that rules out the possibility of it coming from the top of the asymptote because it would have to cross through the x-axis, and we've already established that it can't do that. So does that make sense?
Yeah.
Okay. All right, let's look at 5 and 6. What do you notice about those guys?
They're reciprocal.
They're reciprocals of each other. If you multiplied those functions together, you'd get 1. It's kind of interesting. Well, you get one with some restrictions, but.
Well, so-
Well, what I mean is,
No,
you
no,
get what
I
I'm
get
saying?
it.
Like,
Yeah, I get it. I get it. It was just
Yeah.
funny. Don't worry.
It makes sense. It's just more funny than that.
actually, the graph of these, if you multiplied them, so here's just a fun little food for thought. If you multiply these functions together and graph it, what do you think the graph would look like?
Straight
It would look like
Yeah.
three different lines.
Very
Oh, I
good.
was right.
It would be a straight line of y equals 1, except there'd be a hole at 1,
Two and negative.
2, and negative 2. Isn't that a weird function?
Wow.
Yeah.
Kind of strange looking, but that's what it would look like. Okay, now I think this is cool because I put these on here on purpose because there's some interesting things to think about when you look at a function that has asymptotes and zeros and stuff, and then it's reciprocal. So maybe think about that right now. Like, what's the connection there? Like if this guy has a vertical asymptote, then he would have blank. If this guy has an x-intercept, then this guy would have a blank. So think about that. X minus 1. Okay. Can someone name one fact about this graph?
Two and negative two.
2 and negative 2, and those create. We got a vertical asymptote at 2. We got vertical asymptote at negative 2. Fair enough? What happens at 1? X-intercept. What happens at, or where's the y-intercept? 1/4. Positive, right? Because you have negative 1 over negative 4. Positive 1. So make sure you list that all out, on the right-hand side, 0 gets me 1/4. I get the point 2, 0. I get the point negative 2, 0. There's my, so those are my x-intercepts. That's my y-intercept. Okay, so end behavior. What's this going to approach long term? Okay, so it's a horizontal asymptote. Okay. Now, do you see the shape?
Yeah.
I think so.
Maybe one more piece is over here.
Oh, yeah.
Do you see how we're either going to be all up top or all on bottom here? Which one is it?
Oh, that's fine.
Yeah, plug in a number bigger than 2. 3.
3.
Positive, positive, positive. And I know I can't cross the x-axis because we've already listed out all the possible x-intercepts, and there was not an x-intercept over in this area.
Yeah.
So this part would have to look like this.
Whee!
Is George okay? Is that
wasn't me.
That was Cooper?
Yeah.
What?
I was on.
Okay.
Yay,
Plug in number less than negative 2.
Why did you assume
Not
it was
even
me?
that.
It's literally sounded like your voice. It sounded like you. I'm sorry.
Sorry.
Negative 5 gives you negative over positive, which is negative, which tells us that we are down here. Okay. Another way you could have figured this out was the fact that they do this. Swoop, swoop, is by looking at the factorized version of this bottom here. So now you see if each one individually is an odd asymptote. Okay. I've had that question a bunch of times where it's like, well, wait a second. I thought if the asymptote was squared, it was like doing this. But be careful. This is actually a product of 2 odd asymptotes. Yes, sir.
Your x-intercept.
Oh, what?
Your x-intercept.
Oh, thanks. Thank you. So the graph's right? So just positive 1. Oh, I was writing. Yeah, I mixed up with my asymptote. Sorry. Thanks for pointing that out. The x-intercept is just 1, 0. Just testing you, obviously. Yeah, the vertical asymptotes are 2 and negative 2. So graph looks good. All right, so let's compare that to. Now, what I think is the fun part about, or one of the fun parts about, studying mathematics is just trying to do this next part in your head, which is how will this graph connect to this graph? What do you think happens? So see how this graph is, reaching small positive y values, then 0, and then small negative y values. So what's going to happen around 1 on this graph? Vertical asymptote. And it's going to pass from, from being large to non-existent to large. Okay. Anyway, it's all about reciprocals. So, and then, also like end behavior. If this guy approaches 0, his reciprocal must approach infinity.
Yeah.
So, okay, vertical asymptote at 1.
That means just 2 places that go.
X equals 1. Vertical asymptote. What happens at 2 and negative 2? It's intercepts. 2, negative 2. Y-intercept?
0, 4.
4. Not to scale, but close enough for government work, as Michael J. Knudsen would say.
Fairly, yes.
Is Michael J. still coaching speech and debate?
Yeah.
It is.
You know that he tricked me once? He's like, you'll never guess what my middle name is. I was asking, what's the J stand for? And he's like, you'll never guess. And I found out like years later.
What is it?
What is it?
I can't tell you.
Oh, we've been trying to.
Get right.
figure something out.
J-Y. Your name was.
That's Homer Simpson. In The Simpsons, there's a whole episode where Homer J. Simpson seeks to find out what his middle name is. And it turns out his middle name is J, J-A-Y. Classic episode.
Yeah,
Yeah, do you
is it
see-
something like it's your name?
Huh?
Is it your name?
I actually can't remember it, but it is something like it's not an. I thought it would be like, something crazy, like it's just an insane name, but it's not. Yeah,
Like John or
something
something?
like that. Yeah, you'll have to ask him. He can tell you.
No.
He won't tell us.
Oh, you won't tell you what his middle name is?
No, he won't tell us.
Just like a
Jake.
I'm very open about our family. Frederick. You shouldn't.
Well,
That was the best way to phrase that. Oh, very
All right.
open about my middle name.
are we good on why this end behavior is doing what it does? Like, does that make sense?
Yeah.
So there you go. Interesting there. So what I was talking about before is, look, the x-intercepts kind of map to the vertical asymptotes and vice versa. The end behaviors are sort of reciprocal end behaviors. Even the y-intercepts are reciprocals. 1/4 versus 4, things like that. So, all right, I think that does it. That does it. And
You just never shut up.